Good day, everyone, and our lesson for today is all about linear equations and linear systems, particularly linear equation, linear systems, inconsistent and consistent, homogeneous system, trivial solution and non-trivial solution, method of elimination. In mathematics, a system of linear equations or linear system is a collection of one or more linear equations involving the same set of variables. The theory of linear system is the basis and the fundamental part of linear algebra, a subject which is used in most parts of modern mathematics. Computational algorithms for finding the solutions are an important part of numerical linear algebra and play a significant role in engineering, physics, chemistry, computer science, and economics. Very often, the coefficients of the equations are real or complex numbers, and the solutions are searched in the same set of numbers. But the theory and the algorithm apply for coefficients and solutions in any field. The solutions in an integral domain like the ring of the integers or in the other algebraic structures. Other theories have been developed. In this lesson, our learning objectives are the following. 1. Determine the solution of the system of linear equations. 2. Describe the solution of the system of linear equations. To start with, the study of linear algebra includes the topics of vector algebra, matrix algebra, and the theory of vector spaces. Linear algebra originated as the study of the linear equations, including the solution of simultaneous linear equations. An equation is linear if no variable is in it is multiplied by itself or any other variable. Linear algebra has a wide variety of applications. It is useful in solving networks problems, such as calculating current flow in various branches of complicated electronic circuits, or analyzing traffic flows patterns on city streets and interstate highways. Linear algebra is also the basis of a process called linear programming, widely used as a business to solve a variety of problems that are often contain a very large number of variables. We hoped that in this module you will realize some important aspects of systems of linear equations and its application in our daily lives. The knowledge of mathematics is frequently applied in real life scenario. So basically, linear algebra is used to solve some problems specifically in the linear programming that is used in linear programming, such as analyzing the traffic patterns, electronic circuits. So it is somehow connected to graph theory. Now, as one of the most frequently recurring practical problems in many fields of studies, such as mathematics, physics, biology, chemistry, economic, all phases of engineering, operation, research, and other the social sciences is that of solving a system of linear equation. The equation here, my dear, a sub 1 x sub 1 plus a sub 2 x sub 2 plus ellipses plus a sub n x sub n is equal to b, which expresses the real of or complex quantity b in terms of the unknown x sub 1, x sub 2 ellipses up to x sub n. And the real or complex constant numbers such as a sub 1, a sub 2 ellipses up to a sub n is called the linear equations. So this one is what we call a linear equation. In many applications, we are given b and must find numbers x sub 1, x sub 2, x sub n satisfying 1. So usually, ang hinahanap natin dito, yung value ni x sub 1, x sub 2 ellipses up to x sub n. Depende kung ilan yung given na variables. A solution to linear equation 1 in number 1 is a sequence of n numbers, or it is just a series, such as s sub n, s sub 2, ellipses up to s sub n, which has the property of this number 1 is satisfied when x sub 1 is equal to s sub 1, x sub 2 is equal to s sub 2, ellipses up to x sub n is equal to S sub n are substituted in 1. In short, to satisfy the linear equation, kailangan makahanap tayo ng value ni x sub 1, x sub 2, up to x sub n, kung ilan yung variables yan, para masatisfy natin si letter B at maging equal sila. So, thus, in this example, in this particular example, 6x sub 1 minus 3x sub 2 plus 4x sub 3 equals negative 13. If we will use x sub 1 is equal to 2, x sub 2 is equal to 3, and x sub 3 is equal to negative 4 as the solution to the linear equation, so we will substitute this here na nanggaling dito. So we have 6 times 2 is equal to 12 minus 9 minus 16. Then negative 9 plus negative 16 is equal to negative 25 plus 12 is equal to negative 13. Therefore, we satisfied our linear equation. So ito yung sinasabi nung theory na nandito sa ating discussion. Okay? Now, more generally, a system of M linear equation is n unknowns. X sub 1, x sub 2 ellipses up to x sub n, or a linear system, is a set of M linear equation each in n unknowns. So, a linear system can conveniently be written as, ito siya. So, we have A sub 11, may meaning yung 11 na yan, no? Mamaya, you will see, or maybe sooner, doon sa ating mga later discussion, bakit siya 11, no? Kasi meron siyang kinalaman sa row and column. So, x sub 2 plus a sub 12, x sub 2 plus ellipses plus a, what's that? ln, I think that's ln, I'm not sure. 1n, up to 1n x sub n equals b sub 1. And then another linear equation here is a sub 21 x sub 1 plus a sub 22 x sub 2 plus ellipses plus x sub 2n x sub n equals b sub 2. And ellipses up to a m sub 1 x sub 1 plus a m sub what do you call this, m2 or sub m2 x sub 2 plus ellipses plus a sub mn x sub n equals b sub m. So basically yung 1 dito, yung number 1 dyan, it talks about the column. So pag 1 lahat yan, nasa isang column sila. Pag yun dito naman sa pangalawang digit, we have 1, 2, and n, that is, row pala ito, row, and then yung 1, 2, and n, these are columns. So, yun yung mga columns. Nag-iiba, kung nakikita mo, pareho lang silang 1, 2, and then, dito n, kasi ibig sabihin, hindi natin alam kung pang ilang column yan. But in row, in row naman, ayan, nasa isang row lang siya, 1, 1, 1, 2, 2, and 2. And then ito, M, bakit M? Kasi hindi natin alam pang ilang row na siya. Okay? So, thus the ith equation is AI sub 1, x sub 1, A sub I1, x sub 1 plus A sub I2, x sub 2 plus ellipses plus A sub IN, x sub n equals B sub I. In number 2 equation, the aij, ij are known constant, tawag sila constant. Given values of b sub 1, b sub 2, and ellipses up to b sub n, we want to find values of x sub 1, x sub 2, ellipses up to x sub n that will satisfy each equation in number 2. So, ibig sabihin dito, hinahanap lang natin kung ano yung value ng x, ng mga x's na yan, so that we can satisfy the given equation. Okay, yun ang natin, ng first part ng lesson natin. Now, a solution to linear system number 2 is a sequence of numbers, of n numbers, s sub 1, s sub 2, ellipses up to s sub n, which has the property that each equation in number 2 is satisfied when x sub 1 is equal to s sub 1, x sub 2 is equal to s sub 2, and ellipses up to x sub n equals as s sub n are substituted. So, masasatisfy daw yung solution kung may value dito that will equal to the given linear system, no? Ito yung b sub 1, b sub 2, up to b sub n. Now, if the linear system, number 2, has no solution, pag wala daw siyang solution, hindi siya masasatisfy, then it is to be inconsistent. If it has a solution, then it is called consistent. If b sub 1 is equal to b sub 2 is equal to ellipses equals b sub n is equal to 0, kung 0 yan, no? 0 yung b sub 1, b sub 2 up to b sub n, then number 2 is called a homogeneous system. Note that x sub 1 is equal to x sub 2 is equal to ellipses equals x sub n is equal to 0. Ayan yung mga ganyan. Kung lahat sila is equal to 0 is always a solution to the homogeneous system, it is called a trivial solution. Trivial ang tawag sa kanya. Now, a solution to a homogeneous system in which not all, hindi lahat ng x sub 1, x sub 2, up to x sub n are 0 is called a non-trivial solution. Now, consider another system of our linear equation is in unknowns. So, meron tayong c sub 11, x sub 1, plus c sub 12, x sub 2, plus ellipses, plus c 1 sub 1n, x sub n equals d sub d, sub 1, I'm sorry, c sub 21, x sub 1 plus c sub 22, x sub 2 plus ellipses plus c sub 2n, x sub n is equal to d sub 2, ellipses up to c r sub or c sub r1, x sub 1 plus c sub r2, x sub 2 plus ellipses plus c sub rn, x sub n is equal to d sub r. We say that number 2 and 3, yung 2 kanina, this one, number 2, tsaka number 3, kung titignan natin, they are just the same. So, they are called equivalent if both have exactly the same solution. So, later on, you will see a sample of equivalent. Now, example number 1. This is a linear system, x sub 1 minus 3, x sub 2, which has, meron siyang constant na 3. This one has a constant of 1. Equals negative 7, and 2x sub 1 plus x sub 2 is equal to 7, has a solution that is equivalent to, ano yung x sub 1, that's 2, and x sub 2, that is 3. So, let's see if that's correct. So, let's check this one. So, if x sub 1 is equal to 2, so that is 2 minus negative 3, or I mean negative 3 or minus 3, then x sub 2 is 3. It should be equal to negative 7. So, let's see. This is negative 9. So, we have 2 minus 9. So, the answer is negative 7. Correct. So, it's correct. No? Let's see if they are the same. If they have the same solution or solution set. Ang solution set niya ay 2 and 3. No? So, let's see. 2, yung x sub 1 natin is 2 plus the other one is 3. Okay? So, we have 2 times 2, 4, plus 3. The answer is 7. So, 7 yung nakuha natin. Okay. Now, on the other hand, the linear system, 8x sub 1 minus 3x sub 2 equals 7. 3x sub 1 minus 2x sub 2 is equal to 0. 10x sub 1 minus 2x sub 2 is equal to 14. Has also the same solution as this first one. Okay? Or this one, no? Ito pala yung numbers nila. So, they have the same solution. For x sub 1 is equal to 2 and x sub 2, pareho sila ng solution set. Okay? So, kung check natin, let's say 8 times 2 is 16 minus 3 and 3, that's negative 9. So, 16 minus 9 is 7. So, dapat equivalent sila sa b sub 1, b sub 2, ellipses up to b sub n, kung ano man yung mga yon. Okay? Thus, 4 and 5 are called equivalent. Tawag sa kanila equivalent. to find a solution to a linear system, if wala yung mga solution set na yan and we want to find them so that we can satisfy the given equation, we shall use the technique called the method of elimination. So, ang tawag doon ay method of elimination. That is, we eliminate some variables by adding a multiple of one equation to another equation. So, let's see. Let's try this one. Consider the linear system. So, we decide to eliminate x. So, i-decide natin na ma-eliminate yung x. So, matitira yung y. So, we add negative 2. Right? So, let me use my pen. Let us use red one. Okay. So, ang sabi dito ay try natin yung negative 2. So, if we write negative 2, so that is x minus 3 as, dito na lang siguro na. Okay, we try negative 2 sa first one. I believe all of you are familiar with this math majors because you already took this one, if I'm not mistaken, during grade 8. No? So, this one now is equivalent to negative 2x. Kasi kailangan natin ma-eliminate si 2x, di ba? So, kailangan tayo mag-isip ng number na i-multiply natin kay x or to this equation para makancel natin yung parehong x. So, we have negative 2x minus 3y. Minus plus 6y. Negative 2 times negative 3 is positive 6, then positive 14. And then we have 2x minus 6y equals 7. Okay? So, we can cancel this because negative 2 plus 2 is 0. And positive 6 plus negative 6 is 0 equals 14 plus 7 is 21. We obtain this one. Since 0 yung given natin, and there's no any variable for the or number for y, this means that number 6 or example 1.2 has no solution. Therefore, it is inconsistent. So, kasi wala siyang solution eh. Consistent kapag meron siyang solution. So, let's see another example. Consider the linear system. We have the linear system here, no? Okay. So, let's see. Siguro tingnan natin yung explanation, no? Here. Consider the linear system. Ayan, ito yung linear system natin. Let me use my pen. So, we have x plus 2y plus 3z equals 6. 2x minus 3y plus 2z equals 14. 3x plus y minus z equals negative 2. Let us say that, let us use the second, this is our second, and then this is our third. This will be our first equation, second and third. Let us use the first equation to subtract to the second and third. Okay, to eliminate the x in the first and second equation, we add negative 2 times. We add negative 2 times the first equation to the second one, and negative 3 times the first equation to the third one. Okay, so if we will do that, so let's do the first one. I hope you can see it. X plus 2y plus 3z equals 6. And second equation is 2x. Kasi kailangan natin siya paglaruan eh. So, we have negative 3y plus 2z. And we decided that we will use the number 1 equation to get number 2 and 3. So, the first thing to do is kukunin ko muna yung 1 and 2. So, this is number 1 and number 2. Okay, sabi dito, we need to add 2 times, negative 2 times to satisfy kasi we need to cancel the x. Diba? So, we need to have negative 2 here. So, if that's the case, that will become negative 2x, then minus 4y minus 6z equals negative 12. Okay. So, here pwede natin makancel ito. Negative 3 and is negative 7y, no? Negative 3 and negative 4. And then negative 4z equals 2. So, tama. Diba? Same thing with negative 3 times the first, and the third. So, ito namang first and third. Ganon din yung gagawin natin to satisfy this equation. Okay, so do you want to try? So, let's see. We have the x plus 2y plus 3z equals 6, and 3x plus y minus z equals negative 2. What are we going to do is we need to eliminate the x. So we will multiply negative 3 both sides. Okay. So we have negative 3x, negative 6x, 6y, I'm sorry, negative 9z equals negative 18. Okay. So here we can now cancel this. Therefore, y minus is that? I think that is 6, no? Okay, so this is negative 5, correct? Negative 5y, and then this one is negative 10z. This one's negative 20, so it satisfied the given example. Now, this is a system of two equations in the unknown y and z. Unfortunately, hindi natin ma-cancel yung y, no? Kasi 7 and 5 yan. Pwede tayong mag-isip ng numbers like we can multiply, I think, multiply negative 7 into 5, and then negative 5 into 7 to cancel this and to satisfy our given equation. Pwede naman siguro. So, let's try. Pero, lalaki yung ano natin lalaki yung ating given. But let's see. Kasi we want to get now the z. Kasi we need to cancel y naman. Kasi ang target natin dito is makakuha muna ng isang value. Okay, isang value ng isang variable, which is z muna. If you, decided to get the value of x, so, unang kakancelin mo is z, tapos y, tapos x. Pero we started with x, diba? So, now, let's see, kasi there's another way here, but I thought another way. So, let's see if pareho ba tayo na makukuha o hindi. So, let's try, okay, let's use negative 5 here. And then, let's use 7 here. Kasi they should not have the same, tawag dito, solution, sign, no? So we have here negative 5, negative 7 is 35, 35y, negative, positive 20, z equals negative 10. On the other hand, we have positive 35y plus negative 70z equals negative 140. Okay, so now we can now subtract. I'm sorry, this is negative 35, no? Okay, we can now subtract. Let me check first. Negative. Okay, we can now subtract these two, cancel that one, and then this one, 20z and negative 70. I think this is negative 70, so that is negative 50. Negative 50z equals, that is negative 150. Now, to get the value of z, we need to divide both sides by negative 50. Therefore, z is equal to 3. Z is equal to 3. Let's see if we will get the same as this solution. So, this is a system of two equations in the unknowns, y and z. We multiply the second equation of 8. This is 8. The second equation, which is negative 5, by negative 1/5. So, minultiply siya, yielding 2y plus 2z equals 4. Okay, tama naman. Because negative 20 times negative 1/5, that is positive 4. Negative 10 times negative 1/5 is positive 2. And negative 5 times negative 1/5 is 1. Now, after that, inag-eliminate din sila by multiplying 7 times the second equation to the first one. Na-obtain nila yung 10z and z. I know you know what I'm talking about. So, after nilang makuha ito, mag-multiply sila ng 7 sa y, 2z, tsaka 4. So, nung ginawa nila yon and then pinag-subtract nila yung dalawa, ang nakuha nila is 10z equals 30. Divide both side by 10, z is equal to 3. Yung answer natin kanina is 3, so they are just the same. So, it's up to you which one will you follow. Okay, but in my case, I will follow the first one. Okay, so z is equal to 3. So since nakuha natin is 3, we will use the the second equation. Our second equation here, pwede namang ito. If z is equal to 3, then what is y? If we will use this one, kasi pwede mo gamitin kahit alin dyan, pero this is the shortest one. Y plus 2z equals 4. We want to get y now. Since z is equal to 3, so 2 times 3 is 6. Ililipat mo siya or transposed or use properties of addition of equality. So we have negative 6. So the answer is y is equal to negative 2, right? 4 minus 6 is negative 2. So here we will get negative 2. That's correct. So then, substituting these two values, yz, which is 3 at saka negative 2, to the first equation. Ano ba yung first equation natin? Balikan natin. That is x plus 2y plus 3z equals 6. So, let's see. Ang nakuha natin sa z, anong nakuha natin sa z? That's 3. Ang nakuha natin sa y, that's negative 2. Tama ba? Yeah. Okay, now let's try the number 1 kasi ito yung ginamit natin kanina, di ba? We get this and this, pero ito yung parang instrument natin. If we will use number 1 equation, kasi it's usual. You can use another, but we will try to use number 1 kasi ito na yung x niya eh. Single na. Wala na siyang ibang bigger than one variable, one constant, di ba? So, okay na yung x niya. So, papalitan lang natin yung value ni y, which is negative 2, at saka ni z, which is 3, equals 6. Let's see if anong makuha natin for the x. So, we have negative 4 plus 9 equals 6. This is equal to 5 equals 6, and that is negative 1. So, therefore, x is equal to positive 1, I think. Positive 1. So, x is equal to positive 1. Okay, so we have x equals to positive 1. We find that x is equal to positive 1. That's correct. So, we have now a solution set of 1 for x, negative 2 for y, and 3 for z. We observe further that our elimination procedure has actually produced the linear system. So, x plus 2y plus 3z, this is the equation number 1. So, y plus 2z is equal to 4. This is ito yung number 2 natin. And z is equal to 3. Okay? So, ito yung ano niya, no? Ito yung first equation. Y plus 2z, ito yung second. Dito yan, ito yan. Okay? Ito yung ginamit natin kanina. And z is equal to 3. Nung kinuha natin si y, ito yung ginamit natin. Tama? Kasi given that z is equal to 3. Nung kinuha natin si x, ito yung ginamit natin. So, ito yung equation 1. Ito yung equation number, number 9. Okay? And then, ito yung equation number 10. Ito yan. Number 10. Yan. Obtaining by using the first equation of 7 and the second equation of 9 as well as number 10, yan, 7, 9, and 10, thus the solution set is equal to 1, negative 2, at saka 3. So, x is equal to 1, y is equal to negative 2, and z is equal to positive 3. So, this is our solution set. Okay? Now, let's have this one. Consider the equation x plus 2y minus 3z equals negative 4. 2x plus y minus 3z is equal to 4. So let's see. Consider the equation this one. Okay, so eliminating x, so we need to eliminate. So we add negative 2 times the first equation to the second one. So nag-multiply daw tayo dito. So let's see. If mag-multiply tayo ng negative 2 dyan, since we want to cancel x, so magiging negative 2 yan. So this will become negative 2x. I'm sorry. That's negative 4. Negative 4 y. Positive 6z equals positive 8. And the other one is 2x positive y minus 3z equals 4. So we can cancel this. This will become negative 3, correct? And then this will become positive 3, correct? And this one is 12, correct? Unfortunately, this is still a composed of three variables actually. Not negative 3y plus 3z and then 12. Now, we must now solve 13, solving for y. So we need to solve for y by this solution. So we will what do you call this? Transpose or use addition property of equality. So we have negative 3y equals negative 3z plus 12. And divide both sides by negative 3. I'm sorry, that's negative 3. Then negative 3. So we need to cancel this. So negative 3, that's positive. So z, and then 12 divided negative 3 is negative 4. So we have now the value of y. But unfortunately, this is not yet the value of y. Then where z can be any real numbers, hindi natin alam what's the value of z. Then, from the first equation of number 12, x is equal to negative 4 minus 2y plus 3z. So, ang ginawa ko dito, we transpose, no? Or we use the addition property of equality. So, yung 2y naging negative 2y, and then yung negative 3z, tama ba? Negative 3z is naging positive 3z. Kasi nga, we transpose them. So, y is equal to z equal minus 4. So, pwede tayong maglagay ng value dito. Z is minus 4, and then we have 3z here. So, by multiplying, we have negative 2 times z is negative 2z, and then negative positive 8. No? And then positive 8 and negative 4, that's positive 4. Negative 2z plus 3z is z. So, x is equal to z plus 4. Y is equal to z minus 4. Let's continue. So, this is the solution for the linear system 12 has infinitely many solutions. Every time we assign to the value of z, we obtain another solution to 12. That's true, no? Thus, if z is equal to 1, kung yung z is equal to 1, then x is equal to 5, y is equal to negative 3, and z is equal to 1. If the solution, if z is equal to negative 2, then x is equal to negative 2, y is equal to negative 6, and z is equal to negative 2 is another solution. This example suggests that a linear system may have a unique solution, no solution, or pwede siyang magkaroon ng infinitely many solution. Did you get what I'm talking about here? So, ang ibig sabihin nito, if we will use, okay, since ang x natin, ang sabi dito, since ang x natin is z plus 4 at ang y is equal to z minus 4, kung mag-assume tayo ng value ni z is equal to 1, let's say 1 siya, then that is this one equal to y equals 1 minus 4, and therefore y is equal to negative 3. And if that is 1, then this will become 1 plus 4, therefore y is equal to 5, if I'm correct. So therefore, I'm sorry, x is equal to 5. So therefore, x is equal to 5, y is equal to negative 3, and z is equal to 1. The solution set is 5, negative 3, and 1. So meron siyang infinite. So every time na nag-assume tayo ng value ni z, nagkakaroon tayo ng infinite solution for this. Nagkakaroon tayo ng so much solution. or many solutions, no? Another solution, a unique solution, or yeah. So, magkakaroon tayo ng iba't ibang solutions for that. Infinitely many solution. Yan ang pinopoint ko. Okay? So, for that example, we have an infinite many solution. For example number 3, we have a unique solution. And for example number 1.2, we have no solution. Okay? So that's all about for the linear equation and linear system, particularly linear equation, linear system, inconsistent, consistent, homogeneous system, trivial and non-trivial solutions, method of elimination. With that, thank you very much for your listening.